When we get into doing full-blown hypothesis tests, there's going to be two ways to evaluate our findings. Either we're going to find a p-value for the test and compare that to alpha, and if the p-value for the test is smaller, we're going to say we can reject the null. If the p-value for the test is larger, we're going to say we fail to reject the null. Basically what that's saying is, if the mean were the true mean under the null hypothesis, the normal distribution says we would only see this sample data like 1% of the time. If we set our threshold as we want to be 95% confident, so we're willing to have a 5% alpha where we make errors, then the p-value being 1% would be lower than alpha. It would lead us to reject the null and say that we can statistically prove that the mean is not what it was under the null hypothesis, but instead it's either greater than or less than or not equal to. So that's a lot of words, but basically why I'm telling you this is because the two full hypothesis tests I do after this, I'm going to use a p-value calculation as opposed to a rejection region. That said, you do need to understand it from a rejection region point of view. So what's going to happen is you're going to have sample data to calculate a test statistic. You're then going to look at a normal distribution. And your normal distribution, depending upon the type of test that it has, is going to have a region where if it's beyond that in the unshaded area, it's going to be telling you to reject the null. So in this case, it says a right-tailed test with alpha equals 0.05. Right-tailed means if this is the mean, it's on the right side of the mean, and there's exactly 0.05 area here. Anything that falls to the right of this will be rejected because it's in this region of rejection. We need to find what z-score happens here that has 0.95 to the left of it and 0.05 to the right of it. So what we're really looking up is 0.9500 in the table. We're looking for it in the middle of the table to trace back to a z-score. I need to be on the positive side. When I move down, 0.9500 is in the 1.6 column. So it's happening at 1.645. The way that I got that number in my table, 1.64 and 1.65 on the positive side point to 0.9505 and, 0.9495 and 0.9505. So I was looking for 0.9500. That's right in between these two. That's why I report my answer as 1.645. That starts my region of rejection, meaning if they tell me the test statistic is something like 2.3, 2.3 would be here, beyond my 1.645, in the region of rejection, would lead me to conclude reject the null. If instead my test statistic was something like 0.64, that's here in the region where I would fail to reject, as opposed to beyond my threshold in the region where I would reject the null. So this 1.645 is true of all possible right-tailed tests with alpha equals 0.05. But from the test, you would get a test statistic, which would tell you if it's beyond, reject. If it's still inside, fail to reject. This was for a right-sided test. If instead we have a two-tailed test with alpha equals 0.01, what that really means is that these two areas in the corner total are 0.01. So from the mean, we have 99%, or 0.99 here. But we have 0.01 between the two tails. If there's two tails and they total 0.01, then alpha over 2 equals 0.01 over 2 equals 0.005. So we have 0.005 in this tail, 0.005 in this tail. To find out where that's happening, we again use our sheet. We look in the middle for 0.0050. This is the same thing that we actually did with a 99% confidence interval. So I get the same answer. This gives me negative 2.575. This gives me positive 2.575. So the way that they're going to ask you to do these, entering them into Cengage, is they're going to have a z is less than if it's left-sided, a z is greater than if it's right-sided. So for this first one, there was no left side to the test. It was only right-tailed. That means my z is less than, I should write in capital letters, none, for the system to recognize, no, this doesn't have a left side to the test. For z is greater than, we found the value, 1.645. If they tell you to round to 2 decimals, make it 1.65. For number 7, again, we would have z is less than, z is greater than. In this case, since we have 2 tails, both of them are going to get filled in. The z is less than is going to be negative 2.575. The z is greater than is going to be positive 2.575. Again, if they tell you to round to 2 decimals, just make this negative 2.58 and positive 2.58. Last one here says a left-tailed test with alpha equals 0.1. What that means is my region of rejection is going to be here, 0.1. Everything else is going to be 0.90. So this is 90% confidence with a left-tailed test. Since left tail is exactly how the table is organized, what I'm really looking up in the table is 0, 1, 0, 0. So I go to the negative side, I look down, 0.01, it's happening in the row negative 2.3. And it looks like it's happening precisely negative 2.33 or negative 2.32. Negative 2.33 is 0.0099, so that's closer. That's why I'm going to go with it. Then, when I go to do my z less than, z greater than, it's a left side, so it does have a less than, negative 2.33. When I look at the right side, that's not there, so I write none in capital letters. Just like I said with the z alpha over 2's when we were doing confidence intervals, there's specific ones, there's only a set number of choices here. So really, there's 3 different ways that I can do a test. I can do it as right-tailed, left-tailed, or 2-tailed. There's 3 different alphas I can use. I can either care about 99% with alpha equals 0.01, 95% with alpha equals 0.05, or 90% with alpha equals 0.1. There is a there is a slide in the PowerPoint which tells you literally all 9 numbers that you need to know. You just need to line up, is it a lower-tailed or left test, upper-tailed or right test, 2-tailed test. Once you choose that column, then the rows are the alpha values, line the 2 up, and it'll tell you exactly what these should be. So again, as long as you have your notes done correctly, finding these rejection regions should just be lining things up in your notes.